We have seen that for a plane curve given by the equation f of xy equal to k, we can find the normal vector, and the normal vector will be nothing but a del f value evaluated at the point at which we are seeking the normal vector, and the tangent line equation also we know, that is fx into x minus x naught plus fy into y minus y naught is equal to 0. That is normal vector to a 2D curve is curve given by f of x comma y equal to 0 at the point x naught y naught is del f value at x naught y naught, and the normal unit normal vector is this del f divided by its length, because you have to normalize it. Now the equation of the tangent line is a line at the point x naught y naught to the same curve is given by fx at x naught y naught into x minus x naught plus fy into y minus y naught equal to 0. Let us see an example. Find the normal vector and tangent line to the curve y equal to x square plus 2 at the point 1 comma 3. So what I do is I'll take the equation of the curve as y minus x square minus 2 equal to 0. So your f is equal to 0, right? So f of xy is nothing but y minus x square minus 2. So we will get f of xy is a constant. And the point is taken as 1 comma 3 on the curve. So the gradient vector at any point x comma y is minus 2x comma 1. In particular at x at 1 comma 3, del f value is going to be minus 2 into 1 comma 1. So minus 2 comma 1. So the normal vector is nothing but minus 2I plus 1j. So this is a normal vector, and the unit normal vector is this vector divided by its length. The length is root of 4 plus 1, 5. Root 5. This is the n bar. Okay. Now we are trying to find the tangent line. So equation of the tangent line is fx into x minus x naught plus fy into y minus y naught equal to 0. Here x naught is 1 and y naught is 3. So fx value at 1 comma 3 is given as minus 2 comma 1. So minus 2 into x minus 1 plus 1 into y minus 3 equal to 0. We can write it as y is equal to 2x plus 1. Y equal to 2x plus 1. So this tangent line is now of the form y equal to mx plus c, where m is equal to 2. Okay, this is how we do problems to find the uh, normal vector as well as the tangent line. Okay, if you want the equation of the normal vector, parameterized equation of the normal vector, what we need is the normal vector is actually passing through this 1 comma 3, right? Because the curve is there and you are selected a point, and the normal vector, if you want to see it as a full line, what you have to do is r bar of t is equal to the point at which it is which it is passing is 1 comma 3. So I plus 3j plus t into the line to which it is parallel is minus 2 comma 1. So t into minus 2 comma 1. So this is going to give you 1 minus 2t comma 3 plus t for every t. That will give you this particular line's parametric equation, the normal line's parametric equation. That is how we use the gradient vector to find the normal vector, then tangent line, etc. So now consider a 3D surface, say given by this. 3D surface means a surface given by a function, something like z equal to f of x comma y, or f of x comma y comma z equal to some constant or 0. Such a surface you consider, it's a 3D surface. On a 3D surface, if you select a point, say this point, at this point to this surface there exists a normal outward pointing vector, that is called the normal vector. Okay, so I'm interested in finding what is this normal vector, and through the same point you can have many curves passing through, like through this point along the surface I can take a curve like this, right? This curve is lying on the surface, and another curve can be taken as this particular curve. This is also lying on the surface. Okay, so to this curve at this point I have a tangent vector like this, and to this curve also I'll have a tangent vector like this. Again I can take another curve passing through the same point, and to this curve I can take a tangent vector like this. So considering all these tangent vectors, like there are plenty of tangent vectors, infinitely many tangent vectors will be there, and all these tangent vectors will form a plane. If you consider all the tangent vectors, they'll be creating a plane which is just touching the surface at this point. Okay, that plane is called the tangent plane. For a surface at a given point, there will be a tangent plane. Okay, not a single tangent line. It will be the plane consisting of so many tangent vectors. So they are forming the tangent plane. Now I want to find the equation of the tangent plane, equation of this tangent plane, and equation of the normal, etc. So let the surface equation be f of x comma y comma z equal to k. So surface, say you know that x square plus y square plus z square is a surface, equal to 5 is a surface in the three-dimensional space. This is actually the surface of a sphere. Or if you take z equal to x square plus y square, this is going to give you a paraboloid. Like that, you consider a surface and a point x naught, y naught, z naught on the surface. Now the equation, as I said, the equation of the surface can be taken as f of x, y, z equal to k. Now through that point, there will be infinitely many curves passing through, which all of which are lying on the same surface. So for example, this blue curves are curves lying on the surface. So each of these blue curves will satisfy the equation of the surface, that is f of x comma y comma z equal to k. If this is the equation of the surface, each point on this curve will be satisfying the same equation. Now, as in the case of 2D curves, you can take it as f of x of s comma y of s comma z of s equal to k, where this x of s, y of s, z of s are points on this curve. Now, your function f is now a function of x, y, and z, and this x is a function of s, y is also a function of s, z is also a function of s. So since f is equal to a constant, you can say that df by ds is equal to 0. Derivative will be 0. Okay, but df by ds, you can write it as fx into x dash s plus fy into y dash s plus fz into z dash s. And thus you can write as fxi plus fyj plus fz k dot product with the x dash s comma y dash s comma z dash s equal to 0. Now what is this? This is nothing but del f evaluated at the point x naught, y naught, z naught, and this is nothing but r bar dash s evaluated at the same point. So what it tells you is that del f is having the value 0 when you take the dot product of del f with the r bar dashes. So that implies that del f, as in the case of the plane curves, you can say that del f dot r bar dash s is equal to 0. R bar dash s is nothing but t bar, right? So that's equal to 0. So that happens when you consider a particular curve passing through the point x naught, y naught, and whose tangent is t bar, t bar. Okay. So ultimately, if you take any curve, the same thing is going to happen. So you take either this blue curve or this blue curve, whatever blue curve you take, this del f is going to be perpendicular to the tangent vector at this point, particular point. So that's how we see that del f dot t bar s is equal to 0 for every tangent vector in on this at the point x naught, y naught, z naught on the surface. So you can say that del f is perpendicular to all the tangent vector, means del f is giving you the normal vector, because the tangent vectors, the vector which is perpendicular to all the tangent vectors is called the normal vector, this one. So n bar is actually the unit normal vector, but the normal vector can be taken as del f. If you want the unit normal vector, you have to take del f at x naught, y naught, z naught divided by its length. So this is going to give you n bar. It's very similar to the case when you consider a plane curve. So the next question is, how do you find the tangent planes equation? So del f is equal to fx, fy, fz at the point x naught, y naught, z naught gives you the normal direction. Now I want to find the equation of this plane. This plane is called the tangent plane, which contains all the tangents to the surface at this point x naught, y naught, z naught. So for finding that, you take any x comma y comma z on the tangent plane. X comma y comma z is any point on the tangent plane. Then you connect this line segment. So this point is x naught, y naught, z naught, and this point is x, y, z. So this vector, say if I call it as v bar, v bar is nothing but x minus x naught I plus y minus y naught j plus z minus z naught k, z naught k. Okay. Now you know that this tangent, so that's a vector in the tangent plane. So that vector must be perpendicular to del f. So you'll have del f dot product with the v cap is equal to 0. That gives you that this del f is nothing but fx, fy, fz, right? It's a vector, the gradient vector. So that dot product with x minus x naught I plus y minus y naught j plus z minus z naught k is equal to 0 implies what? That implies fx into x minus x naught plus fy into y minus y naught plus fz into z minus z naught equal to 0. Okay, so this is the equation of the tangent plane. So ultimately it says that if you have a surface given by f of x comma y comma z equal to a constant, then the normal vector is given by del f at that particular point, at which point we are seeking the normal. You consider the del f value at that particular point. That will be giving you the normal direction. And the tangent plane's equation will be given by fx into x minus the x coordinate of the point and plus fy into y minus y naught plus fz into z minus z naught equal to 0. So this is the equation of the tangent plane. So sometimes the equation of the surface may be given as z equal to f of x comma y. For example, the paraboloid can be written as z equal to x square plus y square, right? So that gives a parabola. Parabola rotated gives you a paraboloid. So such a function, if you have, then how to find the tangent plane equation? So what you do is, as in the plane curve, you take this f of x y to the left side, so it becomes z minus f of x y equal to 0. You call this as a new function, g of x comma y comma z. Then g of x comma y comma z equal to 0. So in place of f, you can use this g. So the equation of the tangent plane will be at tangent plane at the point x naught y naught z naught will be gx into x minus x naught plus gy into y minus y naught plus gz into z minus z naught equal to 0 because of this same idea. Instead of f, you have g here because z equal to f I have used. So once you take it to the left side, you can call this as a new function g. Now what is gx? G is equal to z minus f of x comma y equal to 0. So this is g. So your gx is nothing but the derivative of z will be 0 and the partial derivative of f with respect to x is fx. But there is a negative sign. So gx is nothing but minus fx at the point x naught y naught z naught. And what is gy? Gy is the derivative of g with respect to y. So x and z are constants. So z's derivative is 0. There is a negative sign. And f's derivative with respect to y is fy. Okay. And what is dz? Dz is nothing but z derivative is 1. And this doesn't contain any z. So 1 minus 0 or 1 is the gz value. So if you substitute it, you will get the equation of the tangent plane as minus fx into x minus x naught plus minus fy into y minus y naught plus 1 into z minus z naught equal to 0. Okay. Also, you know that z naught is nothing but the value of the function. You have z equal to f of x comma y, right? So z naught is nothing but f of x naught comma y naught. We can say that the equation of the tangent plane is z equal to f of x naught y naught. So you bring this z to the right side and multiply with the negative sign. So you get this equation. So this is the equation of the tangent plane. If the surface is given by the equation z equal to f of xy. Z equal to f of x naught y naught plus fx at x naught y naught into x minus x naught plus fy at x naught y naught into y minus y naught. So this is the definition of the normal vector. Normal vector is del f, and the equation of the tangent plane is the equation of the curve is surface is given by this, means the equation of the tangent plane is fx into x minus x naught plus fy into y minus y naught plus fz into z minus z naught equal to 0. And if the surface is in place of this implicit equation, suppose the surface is given in explicitly like this, z equal to f of x comma y, then the equation of the tangent plane just modifies into z equal to this. This is a problem. Find the normal vector equation of the normal line and tangent plane to the surface of z equal to x square y square at 1 comma 3. So here 1 comma 3 means x equal to 1 and y equal to 3. So correspondingly, what will be the z value? Z will be 1 square into 3 square, so that will be 9. Okay. So g of z x comma y comma z, you can take it as z minus x square y square, and the point can be taken as 1 comma 3 comma 9. So del g is equal to minus 2. Del g is gx gy gz. So gz is 1, gx and gy are minus 2xy square and minus 2x square y. So you evaluate this at the point 1 comma 3 comma 9. What you get is del g is equal to minus 18, minus 6 and 1. So the normal vector is del g, that is this vector. And if you want the unit normal vector, you divide it by root of 18 square plus 6 square plus 1. So the equation of the normal plane at the point P139 is going to be r bar t is equal to, you just need to replace this equation, this normal vector, at the point 139. So the equation of the normal line is the point at which the line is placed plus t into the vector to which it is parallel. Now you know that the normal vector is parallel to del g. So minus 18i minus 6j plus k. And the equation of the tangent plane is given by minus 18 into x minus 1 plus 6 minus 6 into y minus 3 plus 1 into z minus 9. Or if you take to the right side, z to the right side, then you get z equal to 9 plus 18 into x minus 1 plus 6 into y minus 3. So this is the equation of the tangent plane.